Have you ever wondered why some steel connections in a PEB structure are bolted while others are welded? As civil and structural engineers, we often focus on columns, rafters, purlins, and bracing systems. However, one of the most critical factors that determines the safety, stability, and performance of a steel structure is the connection system that holds all these members together. A steel structure is only as strong as its connections. Even if the structural members are designed perfectly, poor connection design or improper connection selection can significantly affect the overall behavior of the structure. In pre-engineered buildings, two major types of connections are commonly used: bolted connections and welded connections. Both connection systems have their own advantages, limitations, applications, construction requirements, and performance characteristics. Selecting the right connection type can directly influence erection speed, construction quality, inspection requirements, maintenance needs, future modifications, and overall project cost. So which connection is actually better for PEB structures? Should engineers prefer bolted connections because of their speed and convenience during erection? Or should welded connections be selected because of their rigidity and structural continuity? In this video, we will explore the complete engineering comparison between bolted and welded connections used in PEB structures. We will understand how each connection works, where they are commonly used, their advantages and disadvantages, practical site considerations, fabrication requirements, inspection challenges, and the engineering factors that influence connection selection. By the end of this video, you will have a clear understanding of when to use bolted connections, when welded connections are more suitable, and how professional engineers make connection decisions in real-world projects. Let's begin by first understanding what a connection actually means in a PEB structure and why it plays such an important role in structural performance. Before we compare bolted and welded connections, it is important to first understand what a connection actually means in a PEB structure and why it plays such a critical role in structural engineering. A pre-engineered building is not made from a single steel member. Instead, it is a complete structural system consisting of columns, rafters, purlins, gouts, bracings, sag rods, base plates, and several other structural components. Each of these members performs a specific function within the structure. However, no individual member can work effectively on its own. For the structure to behave as one integrated system, all these members must be connected together properly. This is where structural connections become extremely important. In simple terms, a connection is the point where two or more structural members are joined together so that forces and loads can be transferred safely from one member to another. For example, when wind acts on a PEB building, the load travels through the roof sheeting to purlins, from purlins to rafters, from rafters to columns, and finally from columns to the foundation. Similarly, when dead load, live load, equipment load, or maintenance load acts on the structure, the load follows a specific path through different structural members. At every stage of this load transfer process, connections play a vital role. If a connection is weak, poorly designed, improperly fabricated, or incorrectly installed, the load transfer mechanism can be affected, which may lead to excessive deformation, structural instability, serviceability problems, or even failure under extreme conditions. This is why experienced structural engineers pay special attention not only to member design, but also to connection design. In a typical PEB structure, several types of connections can be found. For example, the column is connected to the foundation through a base plate connection. The column is connected to the rafter through a moment or rigid connection. Long rafters may require splice connections. Bracing members require bracing connections. Secondary members such as purlins and gouts also require their own connection systems. Although these connections may appear small when compared to the overall size of the building, they are among the most critical components of the entire structural system. In fact, many structural performance issues originate not from the primary members themselves but from connection-related problems such as improper detailing, insufficient fastening, poor welding quality, installation errors, or inadequate inspection. A well-designed connection ensures that forces are transferred safely, structural behavior remains predictable, and the building performs efficiently throughout its service life. This is why connection engineering is considered one of the most important aspects of steel structure design. Now that we understand the purpose and importance of structural connections, let's move to the first major connection type used in PEB structures and understand how a bolted connection works in real engineering practice. Now let's understand the first and most commonly used connection type in modern PEB structures, the bolted connection. If you observe most pre-engineered buildings under construction, you will notice that a large percentage of the structural connections are assembled using bolts rather than welding at the project site. A bolted connection is a structural connection in which steel members are joined together using high-strength bolts, nuts, and washers. These components work together to securely clamp the connected steel elements and transfer forces safely from one member to another. In a typical PEB project, bolted connections can be found at column-to-rafter connections, rafter-splice connections, bracing connections, purlin connections, girt connections, and many other structural locations. One of the biggest advantages of bolted connections is construction speed. Since the steel members are already fabricated in the workshop, the site team only needs to position the members correctly and tighten the bolts according to the specified torque requirements. This significantly reduces erection time and helps accelerate project completion. Another important advantage is ease of inspection. Engineers and quality inspectors can visually verify whether bolts, nuts, and washers have been installed correctly. In many cases, torque testing and inspection procedures can also be performed to ensure the required connection performance. Bolted connections also provide flexibility during construction. If alignment corrections, modifications, replacements, or future expansions are required, bolted connections are generally easier to adjust compared to welded connections. This flexibility becomes extremely valuable in large industrial projects where modifications may occur during erection or future facility expansion. From a safety perspective, bolted connections reduce the amount of welding work required at site. This minimizes dependency on field welding operations, weather conditions, welding equipment, and welding quality control challenges. However, bolted connections must still be designed and installed correctly. The selection of bolt grade, bolt diameter, bolt spacing, edge distance, hole preparation, tightening procedure, and connection detailing all play a critical role in ensuring structural safety and performance. Improper installation, insufficient tightening, missing washers, incorrect bolt placement, or poor detailing can reduce the effectiveness of the connection and affect load transfer behavior. This is why structural engineers carefully design bolted connections based on applied forces, load combinations, and project requirements. Today, bolted connections are considered the preferred choice for many PEB erection activities because they combine speed, practicality, inspection convenience, and reliable structural performance. Now that we understand how bolted connections work, let's move to the second major connection type and see how welded connections differ from bolted connections in structural engineering applications. Now let's understand the second major connection type used in steel structures, the welded connection. Unlike a bolted connection, where separate steel members are joined using bolts, nuts, and washers, a welded connection joins steel members permanently by fusing the steel together through the welding process. In simple terms, welding creates a continuous connection between two steel components. When properly executed, the connected members behave almost like a single structural unit, allowing forces to be transferred efficiently through the joint. This characteristic makes welded connections extremely important in structural steel fabrication and heavy engineering projects. In a typical PEB project, a significant amount of welding is performed in the fabrication workshop before the structural components are transported to the construction site. For example, built-up sections, end plates, stiffeners, connection plates, brackets, and various structural attachments are commonly welded during fabrication. One of the biggest advantages of welded connections is structural continuity. Since there are no bolt holes reducing the net section area of the steel member, welded joints can provide smooth force transfer and excellent rigidity when designed and executed correctly. This makes welded connections particularly useful in applications where high stiffness, permanent attachment, and compact connection details are required. Another important advantage is flexibility in fabrication. Welded connections allow fabricators to create customized structural components, complex geometries, and built-up sections that may be difficult to achieve using only bolted connections. However, welded connections also require a higher level of quality control. The performance of a welded connection depends heavily on factors such as welding procedure, welder's skill, electrode selection, welding position, heat input, joint preparation, and inspection practices. Even a small welding defect can significantly affect connection performance. Common welding defects may include incomplete penetration, porosity, slag inclusion, undercutting, cracking, or insufficient weld size. If these defects are not identified and corrected, they can reduce the strength and reliability of the connection. For this reason, welding inspection plays a critical role in structural engineering. Depending on project requirements, inspections may include visual inspection, magnetic particle testing, ultrasonic testing, or other non-destructive testing methods to verify weld quality. Another practical consideration is site welding. Although welding can be performed on-site, field welding generally requires more time, skilled manpower, proper weather conditions, safety precautions, and strict quality control measures. This is one of the reasons why many modern PEB projects prefer to maximize workshop welding and minimize field welding wherever possible. From an engineering perspective, welded connections can provide excellent strength, rigidity, and structural continuity when properly designed, fabricated, and inspected. However, achieving consistent quality requires experienced personnel, proper procedures, and effective inspection systems throughout the fabrication and construction process. Now that we understand both bolted and welded connections individually, let's compare them directly and see how they differ in terms of construction speed, inspection, modification, site practicality, and overall suitability for PEB structures. Now that we understand both bolted and welded connections individually, let's compare them directly from a practical engineering perspective. One of the most common questions asked by students, site engineers, and even project managers is, which connection is better for a PEB structure? The answer is not as simple as saying bolted connections are always better or welded connections are always stronger. The correct answer depends on the project requirements, fabrication strategy, site conditions, quality control capabilities, and structural design objectives. Let's start with installation speed. When it comes to erection speed, bolted connections have a significant advantage. Since the members are already fabricated and prepared in the workshop, site crews only need to align the members and tighten the bolts according to the specified requirements. This allows rapid assembly. After understanding the working principles, advantages, limitations, and practical applications of both connection systems, we can now answer the most important question of this video. Which connection is actually better for PEB structures? From a practical engineering perspective, there is no single connection type that is universally superior in every situation. Both bolted and welded connections play essential roles in the design, fabrication, and construction of modern steel structures. However, in most PEB projects, bolted connections are generally preferred for site erection activities. This preference is not because welded connections are weak, but because bolted connections offer several practical advantages during construction. Bolted connections allow faster erection, easier inspection, simpler quality control, reduced site welding requirements, easier maintenance, and greater flexibility for future modifications or expansions. These benefits make bolted connections particularly suitable for industrial buildings, warehouses, factories, logistics facilities, commercial steel structures, and many other PEB applications where construction speed and efficiency are important project objectives. On the other hand, welded connections continue to play a critical role in steel fabrication. Many structural components used in PEB systems are manufactured using welding before they ever reach the construction site. Built-up sections, end plates, stiffeners, brackets, connection plates, and many fabricated steel components depend on properly executed welded joints to achieve the required structural performance. In situations where permanent attachment, structural continuity, high rigidity, or specialized fabrication requirements are needed, welded connections may be the preferred engineering solution. Therefore, the decision should never be based on personal preference alone. Professional engineers evaluate multiple factors before selecting a connection type. These factors include structural loading requirements, design philosophy, fabrication capabilities, erection methodology, construction schedule, site conditions, inspection requirements, maintenance considerations, future expansion needs, safety requirements, and overall project economics. A well-designed connection is not simply a means of joining two steel members. It is a critical part of the structural load path that directly influences the behavior, safety, and reliability of the entire structure. Whether the connection is bolted or welded, proper design, detailing, fabrication, installation, inspection, and quality control are essential for achieving the desired structural performance. Ultimately, successful steel structures are not created by strong members alone. They are created by the effective interaction of all structural components working together as one complete engineering system. A safe and efficient PEB structure is achieved when all structural components and connections work together as one integrated load transfer system, ensuring strength, stability, durability, and long-term performance. This fundamental engineering principle should always guide connection selection and structural decision-making in every project. Thank you for watching this video on ACP CIVIL HUB. I hope this comparison between bolted and welded connections has helped you better understand the practical applications in PEB structures and structural engineering projects. If you found this video useful, please take a moment to like the video, share it with your colleagues and fellow engineers, and let us know your thoughts in the comment section. Which connection type do you prefer in your projects? Bolted connections or welded connections? We'd love to hear your experience and professional opinion. And if you're interested in learning more about civil engineering, structural engineering, steel structures, PEB design, construction practices, and engineering detailing, make sure to subscribe to ACP CIVIL HUB and turn on notifications so you never miss future videos. Thank you once again for your support, and I'll see you in the next video.